Hi again. Welcome to the next differentiation video. It describes the way to use the quotient rule when we have a function of x divided into another function and we want to develop a gradient function. The strategy avoids the usual formula and emphasises you developing an easy technique which you can feel in your bones. Once it's there, you won't forget it. It's just like dancing. The quotient rule for differentiation is used when the structure of the right-hand side of an equation shows a fraction with terms in a pronumeral, say in x, in both the top and the bottom expressions. A good example of when we use a quotient rule is when we differentiate y equals 2x minus 3 divided by 4x plus 5. We've got x's top and bottom, or x terms both top and bottom, and we can't simplify that in any way. But just because we have a fraction doesn't indicate we have to use the quotient rule for differentiation. For example, if we have y equals 2x minus 3 over 42, 42 is just a number, and so it has no relevance in terms of differentiation. So in this case, we just differentiate the top and put it all over 42. So it becomes 2 over 42, 1 over 21. Now in the second case, we have a function of x in the numerator, 2x to the fourth minus 5x squared minus 3, over another function of x, 3x squared. But the second function's only got really one term, the 3x squared. So we divide that into each of the terms separately and differentiate. So we have 2x to the fourth over 3x squared, which is 2/3 x squared, which differentiates to 2/3 times 2x to the 1, minus 5x squared over 3x squared, so the x squareds cancel and we're left with 5 over 3, which differentiates to 0 because it's a location constant. And then we have minus 3 over 3x squared, which is minus 1 over x squared. We write that, of course, as minus x to the minus 2. Differentiate that, it becomes plus 2x to the minus 3, or plus 2 over x cubed. So in neither of these cases would we use the quotient rule. So now let's use the quotient rule to that example I gave earlier, which was y equals 2x minus 3 over 4x plus 5. Can't divide them and simplify it anyway, so ideal candidate for a quotient rule. Step 1. Write the two terms in the fraction in order. So the first one is the numerator, the second one we write down as the denominator. Step 2, write each derivative underneath. So the derivative of 2x plus 3 is 2, the derivative of 4x plus 5 is 4. Step 3, always start in the top right hand corner and multiply the top right corner number by the lower left term. So we have 2 times 4x plus 5. A quotient is like subtracting many times, so write down a minus sign after those brackets, and then do the reverse step, multiply the top left by the lower right terms. So we now have dy dx is equal to 2 bracket 4x plus 5 minus from the previous terms, and then we put in 4 times 2x plus 3. We now divide the whole lot of that by the square of the original denominator, and I'll come back to that idea later on. So it's divided by the 4x plus 5 all squared, and then tidy up, expanding the brackets, 8x plus 10 minus 8x minus 12 leaves us with minus 2 because the x's cancel, over 4x plus 5 all squared. Nice and straightforward. Get the rhythm. Second example. See, it's the same steps, so I'm going to leave them there. No changing at all. So our question now is y equals x cubed over 7x minus 1 all squared. A little bit of a chain rule in the denominator there. So it's certainly a candidate for a quotient rule. So we write the two terms in order, x cubed and then 7x minus 1 all squared. We differentiate 3x squared, and then for the second term, 2 comes down the front, rewrite the brackets, 7x minus 1, take 1 off the index, 1 times the derivative of what's inside the bracket, 7. Step 3, always start in the top right hand corner, so it's 3x squared times 7x minus 1 all squared. We then add our minus sign, and then we start in the top left hand side, go to the bottom right, so that's going to be what we had before minus the x cubed times 14 times 7x minus 1. We divide by the square of the original denominator, so 7x minus 1 all squared, when we square that, is 7x minus 1 to the fourth, and then we tidy up. We can see that we've got an x squared term common to both of the numerator terms. We've also got a 7x minus 1, so we'll take them out as common factors, and then we're left with a 3 times 7x minus 1, which is going to be 21x minus 3, and we've got an x times 14 in the next one, so it's going to be minus 14x. That gives us x squared times 7x minus 3 over 7x minus 1 cubed, because one of these 7x minus 1's cancel out. The next example we're going to have to differentiate has bracketed terms top and bottom, and therefore we're going to have to use chain rules for the numerator and the denominator. And we're going to do exactly the same steps. I haven't left them there because we've now got a bit of a feeling for them. So let's go. The numerator term, 2x plus 1 cubed, write it down. 3x minus 5 to the fifth in the denominator, write it down. Differentiate the x numerator term, so it's 3 comes down the front, 2x plus 1, take 1 off, squared, times the derivative, which is 2. 3x minus 5 to the fifth, differentiate, 5 comes down the front, rewrite the brackets, take 1 off the index, multiply by the derivative of 3x minus 5, which is 3. Start in the top right hand corner, multiply by the lower left corner, so we have 6 times 2x plus 1 squared times 3x minus 5 to the fifth. We write down our negative sign, and then we multiply top left by bottom right. 5 times 3 is 15 times 2x plus 1 cubed times 3x minus 5 to the fourth. And then we divide by the derivative, the denominator squared, which is 3x minus 5 to the fifth squared, which is 3x minus 5 to the 10th. We now tidy up. We've got a 3 as a common factor in the two terms in the numerator. We've got a 2x plus 1 squared as a common factor, and we've got a 3x minus 5 to the fourth as a common factor. So we're going to take all of those out, and then we've got left over a 2 in the first term and a 3x minus 5, so 2 times 3x minus 5 is 6x minus 10. In the second term, we've got a 5 left over and a 2x plus 1, so it's minus 5 times 2x, which is minus 10x, minus 5 times plus 1 is minus 5, over the 3x minus 5 to the 10th. We can then take our normal things that are common out the front, and we simplify the last bracket. 6x minus 10x is minus 4x, minus 10 minus 5 is minus 15. So we haven't done anything else to any of the other terms, but now we notice that we've got a 3x minus 5 to the fourth over a 3x minus 5 to the 10th, so they can cancel out to give us a 3x minus 5 to the sixth in the denominator. And we'll also factorise out that minus 1 from the last bracketed term. So we can take out the minus sign, put it at the front, so we've got a minus 3, 2x plus 1 squared, and then the minus out there gives us a plus 4x plus a 15 over 3x minus 5 to the sixth. So it's a more complicated looking derivative function, but still very, very nice. And we said as we went through there were two unusual steps in this rule, and they related to the negative sign and also to squaring the denominator. Now both of these results are explainable by referencing the derivative of y equals 1 over x, and of course with the quotient rule we used an x term in the denominator, and now we write the 1 over x as x to the minus 1. So the derivative is bring down the minus to the front, minus x, take 1 off the index, minus 2, so we can write that as minus 1 over x squared. So we can see from this little example we have a negative sign now produced and also a squared denominator, and that's all leading from having a pronumeral in the denominator of the original function. So our steps were quite explainable. Now to sum up, the quotient rule for differentiation is used when the function to be differentiated is a fraction and has functions of x in both the numerator and the denominator, and we can't divide. So the quotient rule uses the steps we've outlined. I don't think there's a formula for any quotient rule that I've ever heard of. So step 1, write down the two terms in order. Step 2, write the respective derivatives under each term. Step 3, cross-multiply the terms starting in the top right corner. Step 4, write a negative sign. Step 5, cross-multiply the terms starting in the top left corner. Step 6, divide by the square of the denominator of the original function. Step 7, tidy up to make the answer as concise as possible and do not expand any brackets. Easy, hope it goes well. So there is our approach to doing the quotient rule for differentiation. Start with a fraction and then always check to see if you can simplify it. If you can't, then follow the steps I have outlined and you should have no problems. Go and do some test yourself 1 questions on my website, drjaysmaths.com, and then have a look at some of the ways we can apply all the rules to practical problems. Hit the like button and subscribe if you haven't already, then you get notification about new videos. Good luck, see you in the future.